Have you ever wondered how we check how good the parameters are for a given dataset in machine learning? Well, we do that with the likelihood function, and it is a measure of how well parameters of our model fit to observed data. So if we define our model and our dataset, then the likelihood function is simply a multiplication of the probabilities that the model assigns to each individual sample, which multiplication comes from the fact that data points are independent. So in probability, we fix the parameters of the model and then measure the probability of the given data to be in a specific class. While in likelihood, we flip this perspective and say that given these data points, what parameters actually make them more likely to happen. And since we want our data set to be more probable to happen, more likely to happen, we want to maximize the likelihood function. However, since the outputs of the model are probabilities which are between 0 and 1, multiplying them together consecutively will result in various small numbers, and this value is important in training as it provides signal to update the parameters of the model, and if it's small, then the training will be slow. Hence, to fix this issue, we transform multiplication into summation by adding a natural logarithm, since logarithm turns all multiplication into summation. And by doing so, we can have a new form for our likelihood function, which is now called a log likelihood function. And finally, since in optimization packages we usually minimize instead of maximize, we add a negative sign to turn our maximization problem into a minimization problem. And now we have our final formula, which is called the negative log likelihood function. So if you want to dig deeper into this topic, I would highly encourage you to watch my full video on this topic, which I have explained the likelihood function in much more detail with numerical examples.